right. A sequence, I mean, I guess you could say it's a series of numbers, but yeah, it's a list of numbers that follows a pattern. It doesn't have to even be numbers. It could just be a list of items that follow a pattern. I'm going to say numbers because that's what we're talking about, but so a sequence is a list of items, objects, whatever. I'm going to use numbers. Give me an example of a sequence. Okay, what's that? 2, 4, 6, 8. Who do we appreciate? Yes, I keep losing my markers. 2, 4, 6, 8. Give me another one, a little bit more complex. 3, 6, 9, 12. Okay, let's have some imagination. 1, 2, 3, 4. Come on.
Okay. How about this, right? 4, 16, 64.
Okay, that's not a list. Keep going.
I actually don't know what
256 from logs. Yeah. 64 times 4, I believe, is 256.
Yeah.
You gotta have the you have to have the ellipses. What's an ellipses? And it's not a bunch of ellipses. You learn this in English. What's an ellipses? 3 dots. Yeah, these are called the ellipses. If you don't have the 3 dots, it's not a sequence. No 3 dots, no sequence. So ellipse. I think that's how it's spelled. Perhaps.
Yeah.
All right. Obviously, I'm not going to test you, bless you, quiz you, whatever, but it is important to know that. All right. What about? Well, here's someone saying, Corey.
1, 1, 2, 3, 5, 7, 8.
That is a sequence. The pattern isn't totally obvious to some of us, but it is a pattern. How are you getting? Yeah, I just randomly started with 1. No, it starts with 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 would be 13 would be the next one, and so on and so forth. Kaveen, what did you say it's called? I think it was you. Yeah, this is called the Fibonacci sequence. Oh. 2 C's, I think.
Yeah.
Great. Okay. Oh, it is Matt. He's Italian. Brian, you have a question? Okay. You're just trying to make sure you don't fall off the chair? I would appreciate it if you didn't fall off the chair. Okay. So. I'm going to see if your book uses A or T. Your book uses T. Notation is what messes a lot of people up. T sub n is the value of the term. And I'll do a list and so you can figure out what that looks like. And n is the term number. I'll do it, don't worry, I'll do an example of like, what is she talking about? Right now, this is just a bunch of vocabulary. This is just a bunch of vocabulary. Okay, so if I give you a list, let Let's just start with something very basic. Let's just do 5, 10, 15, 20. Okay? Just making it up, and it's not that complex yet. Okay. 5 is the value of the first term. 10 is the value of the second term. So you would say n the term number, 1, 2, 3, 4, dot, 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 dot. The first number in the list is the first term. The second number in the list is the second term. The third number in the list is the third term. Yes? Its value is 5 2. Okay. You cannot have negative term numbers. You can't have negative term numbers. You can't have fractional term numbers. Your term numbers are whole numbers. The first term, the second term, the third term, the fourth term. There's no such thing as the 1.5 term, right? Make sense? Okay, so if I asked you to identify whatever, let's do the sixth term. Sub. Don't say T6. Don't say T6. It's T sub 6. Like literally you say the word sub. T sub 6. So this means the value of the sixth term is, you can figure it out, 30. Okay, so in English, value of the sixth term. 30. Yeah? Okay, so sometimes the patterns are harder to, well, not always harder to find. Okay, so it's a new one. That's the sequence I'm giving you. Does it follow a pattern?
Yeah.
Yeah. It alternates from 1 to negative 1 and 1 to negative 1. So how many did I give you? 1, 2, 3, 4, 5. So what is the value of the sixth term? Essentially, what's the next number in the list? Negative 1. And what if I asked you for the eighth term? Negative 1. If I asked you for the eighth term? Give me some kind of synopsis. What if I asked you to find the 100th term? Do you really want to do one? Yes, Amalia.
All the even term numbers are going to be -1 and all the odd ones are.
That's right. So if we have an even number or an odd number. Now, I'm letting you know right now, that's not great mathematics. It's a good start. It is correct, and for right now, that's exactly how I would write it. Okay, let's do another one. We're only going to do a couple more because I know we have a lot of word problems to go over. New one. What if I gave you 1/2? Sorry, I don't like that. I don't like that. I know 10/5 is not an appropriate number. It should say 2. But it's going to make the pattern a little bit harder to figure out. Try and find the next 2 or 3. Talk to your neighbor. See if you can figure out the next 2 or 3.
I guess. It seems logical to me.
Oh. No. What did I forget?
The dots.
The ellipses.
Do you always have to do a comma and then the ellipses, or does the comma
You
not
know, I don't think it really matters.
matter? Okay.
Sometimes I do, sometimes I don't. Victoria was saying, do you have to do the comma like after the 10/5 before? I would imagine books always do. Yeah, the book. Technically, you should. I don't. Whatever. It's not important in terms of your understanding of the material. Yes.
Does it have to be 3 dots?
No. I believe you're always going to see 3.
Okay.
Oh no, 4. Well, that's 3.
Okay.
Okay, you guys are being way too technical. And then grade your paper and go, oh, there are 5 dots minus 6.
Dang, that's a good help.
All right. I heard a lot of correct conversations, except it is not the top, it is not the bottom. We have to break that vocabulary. It is the numerator and the denominator. Top and bottom is so much easier. I don't really care. It's not good mathematics. Yes.
I got T sub n equals.
We're not doing the whole formula yet.
Alright, okay, so, well, the numerator increases by 30,
Right?
and the denominator increases by 1.
That's correct. So what I ask you to find the next couple of terms?
Yeah.
Okay, so the numerator, you are adding 3 each time. Would you agree with that? 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, plus 3 is 13. Agree? The denominator, what's the denominator? What are you doing each time?
I don't know.
I think we can handle that. 2 plus 3 plus 4, or plus 1, yeah, not too tough. So tell me, 1, 2, 3, 4. The 5th term. What is it, Victoria?
13/6.
13 over 6, yeah.
I don't know how to go further without like having to write
That,
it. Like,
that's. Tomorrow, let's see you guys.
the bottom line can figure out the top.
That numerator and denominator. So Victoria said, you know, the denominator is not too bad. Just keep adding 1. That's not so tough. But the numerator, it's like you add 3, and I think you said something like, I don't know how to find the next term without looking at the one before it.
Yeah, like if
Yeah.
you were to tell me like T sub 18, I would have to write it out.
I would agree, and there'll be shortcuts for that tomorrow. In the meantime, I'm going to make you write it all out. I'm not. So how about the 6th term?
If you have an equation, you could just put it.
That's exactly right, and you will find an equation tomorrow. What do you got? What's the 6th term?
16 over 7.
Okay? Okay, mathematically, in English, this means value of 5th term is 13/6. There's n, there's t sub n. So get used to the lingo. That's all we're going to do for today because we really need to go over word problems, I believe. Yeah? Page 309, 392, and 435. Page 309. Am I right? Yeah, 309? Yeah. What happened here? Okay, so page 309, number 13. Oh, that was about studying. I know I got a lot of questions yesterday, or heard a lot of conversation yesterday about can you get a 0 on the test? Realistically,
No.
probably not. If you oversleep, you might get a 0. But, realistically, you're not going to get a 0.
So you,
Well, you know what? At this high school, you can't get a 0. So there you go. It's impossible to get a 0. So that's the answer to your question. 3. 392. I mean, I'll go over them, but I just want to review the actual context of the problems. Page 392 was kilograms to pounds. That was one problem. The wrench was another problem. And the gas law. Oh, Boyle's law. Chemistry. Well, good. Hold on. We had a no homework weekend. I changed it with you, man. Sorry, this. And I didn't change it on my little agenda. Last night's homework was page what?
309 and
309, number 13.
Yeah.
And what else? So no 392. Thank you. All right, 435. The ship going through the water, high speeds,
yes.
and a young man in sequoia trees. Oh, the tree trunk problem. Okay, so we have three here. We've got the tree trunk, which is number 5. We have the ship, which is number 1. And we have May studying, which is number 13.
It's a question about the homework.
Okay, hold on. Those are the three problems, yes? All right, so look them over. You get 1 vote. Yeah, me.
Do we have to graph?
No. You do not have to graph them.
So what do we actually have to find for the problem?
Okay, hold on. Why am I so discombobulated? Oh, well, you should try to figure out a formula. You may not be able to, but you should certainly try. You're looking at
So basically we just have to find T7, T8.
T sub 7, T sub 8, figure out a formula if you can, and then T sub 100. And if you can't find the formula, it might be a little awful. All right, page 309, test score. You get 1 vote. 309. Nobody wants a test score. Okay. Page 435, number 1, the ship problem. Okay. And number 5, the tree trunks. 1 tree trunk, no. There was 1 for tree trunk and there was 1 for, nobody else has questions. All right, I'll try to get through them both. Ship, high speed. It's quadratic. They tell you it's quadratic.
No.
The ship, page 435, number 1.
Yeah, they tell you it's like that.
Not quadratic.
Well, one of them.
Yeah, number 1 is not quadratic. Have your calculator out. The ship traveling at a high speed through the water. Most of the power generated by the engine goes into the formation of the wake. That's like what it leaves behind, the waves it leaves behind. Oh, that's what it just says. At these speeds, the speed of the ship is proportional. Speed is equals 435.
But it says proportional, but
No, proportional is a fraction. Is means equals. The speed is equals. It says at these speeds, the speed of the ship is equals right away. Proportional to the 7th root of the power being generated by the engine. 72 P per
I
power.
gotta look up how to do that on my calculator.
Carrot.
No, but for like the 7.
Yeah, it's all in the calculator. Carrot. Stay at your calculator.
No, not for that.
Okay, so it's proportional to the 7th root of the power being generated. So S is equal to the 7th root.
I have to go like math.
You can do math.
5.
Yeah.
So like this. Like that. 5.
Yeah, so you just push 5.
No, yeah, but it's a carrot. But I was
You can do the caret either. Like you can just do caret 1/7. Same thing. Yeah. All right. Your ship is going 30 knots. Engines generating 45,000 horsepower. Okay. 30 knots. Seventh root, 1/7 power. I think, my personal opinion, I think that plugging in to the 1/7 power is easier on the calculator than using the 7th root. Doesn't matter. You can do either one. Store. This is not going to be an exact number by any means. 45. Here. 1/7. 6.49 blah blah. So I'm just going to do 6.5. I'm going to store it in K. Store alpha. Where's K? Sorry, hold on. There we go. All right. It's not 6.5. It's 6.49, blah, blah, blah. Write the particular equation we just did. The engines are capable of producing 90,000 horsepower. Holy cow. How fast would you expect the ship to go if the captain gives the order full speed ahead? All right. Let's do here. Thank you. So P, 90,000, plug and chug. Not 6.5. Not 6.5. The number is stored in my calculator. You will get rounding error, and yes, you will lose points. The calculator has the capability to store it. Use it. What am I doing? Times 90, 1, 2, 3. Caret. 33.1-ish knots. I'm not going to lie, I have no idea how fast that is. It's faster than 30. Oh, it's 30 nautical miles per hour. But nautical miles, that doesn't mean much to me either. I'm not well versed in knots and ship speeds, etc. I'll tell you how to round. I generally do the 10th, but whatever. 33.1. All right. Does doubling the power cause the speed to double? What's the answer to that? No, why not? Why does doubling the speed not double the power and vice versa? Well, most of the energy goes into the weight, but mathematically, like that logically makes sense, but mathematically, how do you know that doubling the power doesn't double the speed?
Because
They're not exactly proportional. They're not exactly proportional. It's not like this, whatever, you're going, the power is 1 unit and the speed is 1 unit, and the power is 2, and they're not directly proportional. Why do you suppose that ships do not go much faster than 30 knots? What we got here, P? No. S. Why is the speed? Yeah,
got 33.
Okay.
It's like,
That's not much.
I mean, it's not much of a difference.
You're right.
but
We
like,
did, no, she's right. We did get 33. So the generic question is, why do they not go much faster than 30? So I guess it's, it's relative. Why do we think they run out of fuel
They
faster?
wouldn't be able to stop us quickly.
They won't be able to stop as quickly?
Yeah,
In general, right? Anything that goes too fast, you won't be able to stop as quickly.
Do they have like a speed limit on the water?
I would imagine so. I know that like speedboats and things like that do, for sure. Because you're sharing water with other speedboats. But like cruise ships and stuff, you're out in the middle of nowhere. So, this is totally unrelated, but, right, like the Titanic, they decided that they were, they had open water and they were going to go faster. And the engine couldn't handle it, so. Do we have any ideas other than fuel and wake and inability to stop?
Probably like really, really fast and then they're gonna flap them up.
Let's hope not.
It's heavy
What's heavy?
and
Okay.
it takes more fuel. It's like a rocket science. But
Well, that's what was happening with,
I just said too big.
I think it was, someone said about the fuel. All right, let's move on. There was a question about part 437, number 5, the tree trunk. Yeah, there was a question about the tree trunk. Okay. Thomas McMahon.
he demands.
Thomas McMahon reports in the July 1975 issue of Scientific American that the base diameter of a tree's trunk varies directly with the 3/2 power of its height. Base of the tree's trunk varies directly. All right, what variables do we want to use? Power of its height. I just asked you, I'm going to use H for height for sure. What other variable do you want me to use? Try to break yourself of X and Y. E? Oh, P, D.
B for base.
B for base, D for diameter. You want to Rochambeau over it, or can I just pick? Great, I'm using B. The base diameter of a tree's trunk varies directly. Okay. D is fine too. Okay, so help me out. We've got, it varies directly with the 3/2 power of its height. Yeah, you need another variable. You need another variable and you have to figure out what A, K, whatever is.
You just
Okay,
throw it
it's
in front.
Make it a coefficient, always. Always.
Nope, it's not.
No, but that's important.
A young sequoia tree, 5 meters tall, has a base diameter of 14.5 centimeters. Write the equation expressing blah, 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 blah. Okay, the tree is 5 meters tall.
That was
Okay.
Plug and chug. I'm going to cheat. 1.3. Is it exactly 1.3 or is it approximately 1? Approximately. I'm going to need to store it. So, the base yeah. All right, so as you know, if you can't get the equation, you can't answer the rest of the questions. So you need to make sure that you're paying close attention to the details. What would you expect this tree's diameter to be when it has grown to a height of 50 meters? It's pretty tall, yeah? 50 meters? Units and yards.
What's a meter then?
It's a little more than a yard.
A meter's a little more than 1 yard, correct?
It's like 3.3.
Oh, so it would be like 150-ish. All right, height's 50 meters, so here we go. No, not 150. Oops, I added in an extra number there. Slightly changes the problem. Straight plug and chug. Make sure you have the number in your calculator. 459. I cheated. That's what the book says. 459? 460-ish?
A meter is 3.3.
Does making the height, you guys stop. Does making the height 10 times as big make the diameter more than 10 times as big or less than 10 times as big? What did it say if I multiply by 10? If I make it 10 times as big. How are you gonna figure that out? No one? Height 10 times as big. All right, all of you that are working on the head of the homework, help me out here. Homework due today. Brian, you guys, help me out.
No.
5C. Why not? The answer is no. Why not?
Yeah, because
Number 5.
Give me a value for H. Give me some random value for H.
The height isn't the constant.
The height's not a constant. What do you mean height's not a constant?
So it doesn't, like, the slope is, okay, it's like, the height isn't constant, so when you, round out it.
Give me a random value for H.
4.
4. Okay. So I mean, this is a longer way to do it, but figure it out. If height is 4, then what's the base? Plug in. Plug in.
Is it 6? Oh, but I don't remember.
We'll just get close enough. I understand what you're saying.
I don't know, okay.
I got 96.
I get 10.4. If the height is 4, then the base is 10.4. That's what I got. Agreed? Okay, so what is, they want to know 10 times, right? So if H is 40, B should be 100 point something. That's how you can check using numerical values. If H is 40, you don't get 100, do you? Or whatever it is.
You're like 220.
So if H is 40, B is 328.9, let's say. 10.4 is 328.9 is not 10 times more than 10.4. 328.9 is not 10 times 10.4. This is a lot more. So does making the height 10 times as big make the base 10 times as big? No, it makes it like 32 times as big. So that's how you can show mathematically. And you can pick any number you want for h. If h is 6, blah, blah. And then, not double it, multiply by 10, you get 60, da, da, da. You get 32 times, no matter which way you do it. It is difficult to measure the height of a tree. Yes, especially when it is a dense forest. But it is relatively easy to measure its base diameter. The largest known sequoia at the time of publishing, which I think is still true, the General Sherman in California, which is in Kings something National Park.
Is it far?
It has a diameter of 985 centimeters, which is the size of a small house. It's ginormous. How tall is it? Plug in 985 for B. You have to know how to solve with the fractional exponents. You have to know how to solve with the fractional exponent. Divide by 1.3.
I'm still doing it with 5, right?
This is the last card.
The exponent should be 3 houses.
Thank you. Yes, yes, yes. Thank you.
Where'd you get 1 7?
The other problem.
Because I made a mistake. Raise both sides to what power? Thirds. Thirds. Parentheses. 2/3. Holy
What's the higher?
guacamole.
One over.
Is that right? Is that right? No, that's not right. Oh, yes, because I am in centimeters. This is not right. I did something wrong. What did I do wrong? Help me out. My calculations. There's an error. This is not right. That's my mistake. I don't know where I got that number from.
0.5. But this still didn't seem right to me because 83.27
Meters. Oh. Yeah, that'd make a big difference.
I was like, how can it be a tiny tree?
The good news is that you recognize. That's good. You recognize your answer as a
1 minus 2.
Staple.
If necessary.